So in this problem, we would like to use the method of Lagrange multipliers in order to find the minimum and the maximum of the function f of xy equals x squared minus y squared on the ellipse x squared plus 2y squared is equal to 4. So let's just note that in this setup, the method of Lagrange multipliers can be summarized as follows. If we have a level curve of a function of two variables defined by g of xy equals 0, and we want to find the critical points of f of xy on this curve, then what we need to do is consider the system, the gradient of f being parallel to the gradient of g. This is implemented by saying that it's a scalar multiple of the gradient of g, hence the auxiliary unknown lambda, and then set g equals 0. Again, this method gives us critical points, points where a local minimum or a local maximum could exist. However, if the constraint defines a compact set, in our case that's an ellipse, then the minimum and the maximum are guaranteed to exist, and all of a sudden the critical points turn into the only candidates for extrema for that function. So let's see how this is done then for this particular function. So we need to define a function that gives the underlying constraint. So we define g of x y to be equal to x squared plus 2y squared minus 4. So we bring all the quantities on the left of the equation. And then we consider the system. The gradient of f equals lambda times the gradient of g, and g equals 0. Let's rewrite this as the gradient of f is 2x comma negative 2y equals lambda times the gradient of g, which is 2x comma 4y, and we would also like to have x squared plus 2y squared minus 4 equals 0. Okay, so let's further elucidate the system. So let's write it as 2x equals lambda times 2x, and negative 2y equals lambda times 4y, and x squared plus 2y squared minus 4 equals 0. We can further simplify this by dividing the first equation by 2 and bring everything over to the left-hand side. So x minus lambda x is equal to 0. For the second equation, I think it's enough to just divide it by 2. So minus y is equal to 2 lambda y. And the last equation, let's leave it as it is. And our starting point here will be the first equation, because we can easily factorize it as x times 1 minus lambda equals 0. So this gives us two possibilities. One of them has to be true. X equals 0, and 1 minus lambda is 0, which means that lambda is 1. Okay, so let's start with the first one. So if x is 0, then let's go to our constraint and plug in x equals 0, and that will give us 2y squared is equal to 4, which means that y squared is equal to 2, which means that y is equal to plus or minus the square root of 2. So this yields 2 points, 0 comma square root of 2 and 0 comma negative square root of 2. And then let's consider that lambda is equal to 1. If lambda is equal to 1, now we go to the second equation. And the second equation tells us that minus y is equal to 2y. Okay, the only way that this can happen, just bring the negative y over to the right-hand side by adding y, and you will find 3y equals 0, which means that y is equal to 0. If y is equal to 0, then we go back to our constraint, and this gives us x squared is equal to 4, which means that x is equal to plus or minus 2, and this yields 2 more points, 2, 0, and negative 2, 0. So we have a total of 4 critical points, and again, the extrema are guaranteed to exist. Hence, we can form a little table here and put all these points on the table and evaluate the objective function at these points. The idea is that since the extrema are guaranteed to exist and these are the only candidates, then we will have that one of them has to be the minimum, one of them has to be the maximum. Specifically, the one that gives the largest output will be the maximum. The ones that gives the largest, the smallest output will be the minimum. So our objective function was x squared minus y squared. So this will give us minus 2 here, 4, and 4. And this means that we have 2 points of minimum. So this is a minimum, this is a minimum. We can see both the input and the output for that minimum, and also 2 points of maximum. And that's all. Thanks for watching.